Welcome everyone. Today we have our another new episode. We will discuss about IoT, 5G, age of computing. We have our world famous speaker, Mr. David Schumacher, Mr. Edward, Mr. Donalds, Mr. David Smith, and Mr. Marshall. So I want to start from Mr. David Schumacher. How you want to discuss about IoT, 5G, and edge computing? This is very popular right now. Yes, Asia Pacific. We are doing a lot of research. So what you want to share with us?
Good morning, good afternoon, good evening, wherever you are in the world, or today, or whenever you replay this. Just quickly, because I know there's a number of people that have some interesting things to say on this. Want to give just a real quick definition of each one of the three things we're talking about to make sure we're all talking about the same thing. So, Internet of Things, physical objects that have computer processors embedded in them, connected to the networks, sharing, distributing data. 5G, as we're talking about it, fifth generation telecom broadband technology. It's been rolling out for the last couple of years and still has a way to go. It's the successor to the 4G LTE. And edge computing, it's a model for distributing processing out to the edges, closest to the source of the data, what we might typically think of users, or where data collection is coming along. And as I think about these things, it reminds me of a quote from Helen Keller that says, "Alone we can do little, but together we can do much." And the reason I bring that up is these three technologies really blend and work well together. For example, in the 5G towers that are rolling out here in my hometown of Phoenix, Arizona, the carriers that are doing this are virtualizing the computing environment much closer to each one of the cell phone sites to be able to process the information that comes in from 5G. 5G reduces latency, it has increased speed, but we still have an issue with backbone connection back to a central cloud system. So computing on the edge allows for that work to be distributed, and then you have back-end connectivity that connects the whole network together for updates or for information that needs to go out across the entire network. As I was looking around, I found a couple of interesting places where 5G is being used. Mercedes-Benz, for example, as part of their advanced drive assistance systems, has real-time sensors on the cars that they're embedding. Because of the real time, and that's the aspect of it with the speed and the quick processing, they can authenticate and lower the risk of hacking for these highly technical cars. By the way, the virtualized environment that is used, virtualized network, virtualized processing on the edge, closer to the cars in this case, is what allows that speed. It allows that instant authentication. There's uses in autonomous vehicles, which are tested here in my hometown. And then I was thinking, taking us back to Internet of Things, imagine a factory where IoT devices are monitoring and controlling all the processes that are involved. Just a single factory. And what that flood of data would look like going to a centralized cloud location. So edge computing allows for that processing once again to be done more locally and then shared on the back end, only what needs to be shared up and distributed to the cloud and avoiding the need for big data pipes and big costly expenses going to the cloud. So the sharing can be easier. So quick, brief introduction, because I know there are so many more that have to say. I know Edward has a report that he wants to talk about, and I know that there are others, so I'm just anxious to hear what they have to say.
Thank you, Professor Edward.
Well, thank you, and of course, excellent opening remarks, David, as you always do, and I will try to build on those. The Sharif's excellent shows are always focusing on different technologies. virtual reality, augmented reality, artificial intelligence. You can go down the list, look at all the great shows. But all of these technologies and the contribution they can make to our future all rely on connectivity. If they're just kind of sitting here, if this wonderful machine here, I'm holding up a little Apple book here. If all of these are just kind of sitting on my desk, well, it's nice. I can do all sorts of cool stuff on it. But the connectivity, as David has indicated, is really what is important in the future. The estimate is that by the end of the decade, we're going to have 500 billion sensors in this world. I forget who it was who basically said the world is kind of growing a virtual skin. Everything from temperature sensors to light sensors to, just everything you can think about. And they're all going to be interconnected. So take 500 billion sensors, multiply it by all those connections, and I'm sure somebody on this call will talk about how, whether it's more atoms in the universe or whatever. The amount is incredible, but somehow these all have to be connected together. That's what's important. That's why 5G is so important. Obviously, we think of the connectivity like we have right now, but machine to machine, sensor to sensor, these kinds of connections are going to be what's important in the future. I'm especially keen, as many of you who've listened to me know, about the medical applications. I just saw another video recently about a remote surgery, somebody doing a surgery from one part of the world to another, and actually a surgeon operating. This is incredible. And again, I think that this is going to be key to going from a sick care system, which is what we have today in our country and in the world, to a real healthcare system. But I wanted to call attention. I have to jump off in just a second here. A very interesting report, some of you may be familiar with it, Samsung has put out on 6G, the next hyper-connected experience for all. And I suggest you take a look at this study, and I can put the link into the chat or send it to you, Sharif, so you can send it along to anyone who's interested, because this study is going into some detail. I mean, it has some very good graphics in it, and I'm just holding up the first one. It has a very good outline of how to think about not just 5G, which of course is coming in right now in this country and elsewhere, but 6G, which the prediction is that by 2030, when we have those 500 billion sensors in place, we're going to be using 6G. That's the thing about exponential technology. It's not, well, we have this nice thing in 20 or 30 years, we may have another nice thing. It's an ongoing process. So I really urge people to, I can't go over all the material in this study. Some of you may have read it already. And again, I have to jump off in a second here, but anyone who's listening, you're going to find this a fascinating discussion, and I hope you'll take a look at some of this and other studies that are coming out, because this is really looking ahead to the future. So anyway, those are my comments. And again, 5G and going on to 6G and connectivity is really going to be what's important in the future, and taking all these wonderful technologies and pulling them together so we can have, for example, instead of a sick care system, a healthcare system, the kind of Internet of Things we're talking about. And also, this is absolutely a fascinating topic, and I want to thank Sharif for highlighting it for us today.
Thank you. We always focus on the topic where there is a demand from Asia Pacific. Even we always connect with the different corporations and academy. They always say they always try to engage with our topic, and this is really, really important for Asia Pacific, because even example, Malaysia, they are looking for 6G. They're doing research and they're developing like joint ventures and this kind of thing. So we are open for any good discussions and any good collaboration. Professor Donor, how you want to analyze to this topic?
Well, I want to just add one thing to it, is that 5G is it's going to take a while, because right now there's 3 levels of 5G. So there's basically full 5G, fast 5G, mid 5G, and low 5G. And in order to get the really fast 5G, you have to be about 80 feet from the tower. And so it's not something that's very widely available. It's only available in very dense city cores. So if they have it inside of stores, sometimes inside of football stadiums, things like that, where they can have the towers very densely together. And it's really basically like Wi-Fi. It's really what it is. And it's very similar. And then when you get to the low 5G, it's just about the same as 4G. It's really not that much difference. And so the kind of latency that we're hoping to get with 5G is somewhat in the future. And I think that talking about 6G right now might be a little bit premature, since it's going to be a little while before we actually have 5G. I think the edge thing is really fascinating. When I was working at NetApp, I'm kind of somewhat of an expert at how file systems work. And we got into this amazing thing with really, really high bandwidth connectivity, where you could actually, what happens when to have redundancy in a file system, when you write a block to a disk, what you do is you write it in more than one place. And so, and then because of that, if one of your disks goes bad, then you can just get it from another disk. And then you can also ask the question, which disk is busiest right now? And then you can get the block from the disk that's the least busy if you're reading it, and things like that, to make it happen faster. And so we're getting to the point where you can have a local version of the block and a version of the block in the cloud at the same time in the file system. So you ask the question, where am I going to write the block? And you can write it and have a redundant copy at the same time in the cloud, which is really amazing. So that's an example of edge computing. Another one that I just came across is the new, what are they called? The new tracking device, personal thing from Amazon. I forget what it's called now, but actually I could look. I've got it right here. Anyway, they don't have the name on the box. Anyway, it has a feature where it'll analyze your voice tone to tell you how you're coming across to people when you talk. So are you coming across as pleasant or unpleasant? Are you coming across as angry or whatever else like that? And when you do something like that, in order to do it, you have to train it. And training deep learning systems is incredibly computationally expensive. So what they do is they have, giant rooms full of GPUs, just thousands and thousands and thousands of GPUs that they use to train it. But once they train it, they can take this trained little piece of code and then download it into your phone, and it'll actually run completely in your phone. So it's totally privacy. They download this little piece of code into your phone, and it'll do the analysis right there on your phone. So that's an incredibly interesting use of edge computing, where you can train the deep learning centrally, and then download the actual recognizers and run them locally. So edge computing it's ubiquitous, and as people pointed out, there's devices everywhere. I remember when I was teaching about the internet early on, I got into it right at the beginning, and I told people, I said, someday your watch and your microwave and everything are going to have IP addresses. I was explaining to them why we had to go from IPv4 to IPv6. And I said, we're going to run out of IP addresses. And they're like, what? And I said, no, you don't understand. We're going to have trillions of devices, and we're going to need all of those IP addresses. And turned out that's the way it is now. Everything around us, and I got a little cap for my camera now. I actually shut it off. I make it so it can't watch me when I don't want it to, because hackers can get into it. I know hackers can get into it and watch me. I don't know why anybody would want to, but it's these devices are everywhere. So I would just say one other, my refrigerator. Look, I can get on my phone and I can look and see at the store, and I can look and see what's in my refrigerator at the store. And that's just the world we're living in. That's IoT. That's the Internet of Things. And it's pretty exciting. So that's all I can say right now.
Thank you, Professor David Smith.
I agree with what David and Donald have said, is that everything is connected today, but everything's connected today because we've become digital. And digital is what's driven this connectivity. And the reason edge computing is becoming so important is we're beginning to put devices into the network that need to act in real time. When we were not moving towards real time with our sensors, our IoT, the other devices like that, the model of bringing everything back to a central core kind of made sense. But when we have to cut latency down, reaction time, the amount of data we're transmitting, that's where edge computing shines. As you heard, the amount of data a car generates in autonomous mode is tremendous. Today, General Motors says that just with the sensors they have in their cars today, it's generating 4,000 gigabytes of data today that in most instances are thrown away because it's really not in that fully connected environment yet. But to me, there's some other interesting elements in it. Dell Computing's in a recent thing started talking about the generations, that how 2G changed work, 3G changed business, 4G changed culture, 5G changed how the world see itself, and 6G is going to provide the interconnectivity to get things done. But particularly when you come to Internet of Things, 5G is not the saver of everything. If I go into my house and look at the Internet of Things sensors I'm putting in my house, 5G consumes too much power. It draws battery. The 5G radios really draw battery big time. So there's some other standards that are coming out to play in the marketplace where you begin to see the 5G being utilized. One of them, which is interesting, was a proprietary format, is called low rate, LORA. And it was developed for very low powered wire area networks. And that's where the 5G is supposed to be a solution, but the power requirements and things are driving it other ways. The other thing that's interesting is 5G's promise is it's high bandwidth. Many of the sensors, particularly the sensors in your homes, are very low data rates. They're doing 1 or 2 kilobit type of data rates, where the requirements for the higher bandwidth of 5G isn't necessary. And the penalty of the battery lives isn't warranted when you have that type of documents, that type of draws as well, the data rates. So you're going to see multiple things besides 5G play in this as you go. But IoT, 5G, and edge computing are the core of the system. And particularly when you go into homes, into shops, and things like that, you're going to see these other protocols be added to that stack to make it more efficient and effective in the day-to-day work that we're doing. But I can tell you, we're going to see edge computing continue to be enhanced. Today, it's smaller ones. You're going to see larger edge of cloud computing come in place in the years too, as the sensors go up, as IoT goes up. And as we look at the movement towards real time and autonomous activity, that's going to require real time.
Thank you. Mr. Marshall.
Yeah, so all excellent contributions to this conversation of these three different topics that are combined. I actually have experience in working with 5G companies. So one of the things that we discovered, there was a few takeaways that are still relevant. Some of them are not, as David just pointed out. The bandwidth is different for each of these different Internet of Things. But basically, 5G has been deployed in areas in the United States, and there's a race among Japan, South Korea, China, and the United States to be the dominant winners in 5G, and obviously 6G beyond that. Interestingly enough, the United States won the 4G LTE race to begin with, but now China is actually taking the lead in the global race for the successful deployment of 5G. And I say successful because it's not yet totally successful, has been pointed out by a lot of the speakers here. And most wireless network consumers do not have access to 5G for the very reason that David Smith up is that it consumes a lot of power. However, we do know that some of the providers are working to change that, because and some of that change is not driven by 5G, it's driven by the towers themselves, how they're deploying them, redeploying them. Like 4G LTE networks are being converted to 5G networks. That's happening with AT&T. Sprint just got bought out by another company, and they're converting that in our area here in the Northeast. But basically, these companies all need to create comprehensive spectrum strategies. In other words, what is the spectrum that they can address with their 5G? What kind of Internet of Thing devices can they operate? And they have to develop 5G customer offers that will be coincide with the capabilities that they really have and what they're capable of delivering. So the developers are now organizing networks and rollout operations as we speak. The goal was to get everything done by 2020. We're now in 2021, the end of it, and they're still not done. And they're still working on that. I noticed that I think it was David Shoemaker that talked about surgery, or somebody else did perhaps, but live surgical capability has to do with latency on the network. 4G LTE doesn't have the latency to do hands-on surgery. You can do like consulting type surgery, but to actually do the surgery itself, you need a zero latency or close to it. 5G offers the promise of that, and certainly 6G beyond it. But without that latency capability, all the as Donald talked about, all the IP network devices and all the IP addresses are just going to grow exponentially. But the beauty of 5G, as opposed to the 3G, 2G, 1G, and 4G LTE before, is exponentially wider bandwidth and capability of handling the amount of technology and a lot of devices that it can, especially with the latency issue addresses that. 5G, in my opinion, is going to transform the world into a connected, data-driven society, as opposed to not that we aren't already data-driven, but it's going to be data-driven real time. That's a big difference. Right now, if I look at data, my data has a latency on it, and it causes different things. Now, there are trade-offs on this. The trade-offs is there's positives and negatives. I just heard today on the BBC, they had a documentary about how terrorists are using real-time data to identify people through their photographs, program an algorithm so that in a year or two, it can go out and send a drone and knock somebody off. That's crazy. But that's what people are. So there's trade-offs. There is pluses and minuses.
And that's where regulatory process comes into play for all the countries that are involved in this. We need stringent regulatory process of where the data is being used and how it's being used and who's using it, in my opinion. Using it for medicine, great. Using it to knock somebody off, not great. So I think it's something that we need to think about and we need to take into under consideration. And I'll leave it at there right now.
Thank you, Professor Rob.
Sure. Good morning. Okay, a lot to parse. 5G has a number of distinct advantages over 4G. Bandwidth has been mentioned. The other one is performance at the edge. 5G is one of 5G's big performance advantages that's been highlighted and demonstrated a number of times has been the fact that with 4G you get a major drop in performance at the edge of coverage. 5G you do not. It supports high performance at the edge. When we're talking about IoT and computation at the edge, the goal is to reduce network traffic. And so what we do is we do some of the initial AI processing at the camera, at the sensor, and we only send through a subset of that information so that the network isn't compromised by traffic and that you get a relatively quick response from whatever the control infrastructure is. Because the idea is if you, for instance, with traffic cams, if there's an accident that occurs and you want to redirect traffic, that's got to happen pretty fast. On the other hand, with weather sensors, you may not need millisecond response times because weather tends to change relatively slowly. However, if you've got a tornado forming, that changes quite a bit. I mean, the requirement's quite a bit different. You may need a much faster alerting structure so that people are notified that they've got problems and they can seek shelter with as much time as possible. Same thing with earthquake. The amount of notification you get with an earthquake event is relatively short, and so the faster your sensor network is, the better off you're going to be in terms of being able to respond. We just had a discontinuation of 3G here in the United States that showcases the constant cycle of the networks, and a lot of folks were surprisingly hurt by the discontinuation, largely because alarm systems had gone to a large extent to 3G in terms of reporting, and now a lot of those alarm systems are dropping out of service, or at least with regard to the remote reporting, because the 3G network that they required is no longer functioning in their area. Coverage in 5G's been a little sporadic. For instance, here in Bend, we've got 5G coverage. The merger of T-Mobile and Sprint has done some rather nice things with regard to getting coverage here, and actually at the house, I've got 5G coverage for T-Mobile, AT&T, and just a touch of Verizon. Verizon was particularly aggressive here in the United States with regard to 5G rollout. The concern with regard to being able to do IoT and computing at the edge is when you limit the information that's being transferred centrally, you may be creating bias. So if, for instance, if you set up security cameras and those security cameras are set up only to identify people that are coming through that may not be part of your employment structure, it may miss an employee that's coming to work that's carrying a weapon. So where a security camera might previously have alerted that you had a dangerous event, unless that AI in the security camera was programmed to identify anomalies like weapons, there's a reasonable chance that that camera is not going to transfer the image that you need to go to the security central station because it's not looking for that particular aspect of the person that's behaving badly. And the end result is instead of getting a faster reporting of a problem, you may not get any reporting at all until you actually have an event. And of course, with regard to security, you want to prevent the events. It's not just reporting when you've got a theft or a shooting going on. It's trying to prevent those things from happening in the first place. And so a great deal of care has to be taken when you're programming these endpoints to make sure that they're not cutting off critical information that you need for decision making. And that's where the heavy lifting occurs. You really have to think through the entire ecosystem and think through what it is you're sending. You're stripping away before you send the data centrally to make sure that that's not going to result in bad decisions and bad decisions at scale. Now, this is something we're struggling with for a while. Now, there's been some mention of 6G. 6G is pretty much all smoke and mirrors now. Depending on who you talk to, A 6G can be anything from a use of radiation for transmission, which is what some companies are talking about in order to penetrate things like tunnels, or just a faster implementation of 5G with even higher bandwidth and even lower latency. We haven't mentioned millimeter wave. Millimeter wave rolled out along with 5G, though it has not been rolled out consistently internationally. Millimeter wave is largely used inside buildings where your typical 5G infrastructure is used outside buildings. Millimeter wave tends to penetrate a little better, and you can more easily put in repeaters inside a building to get coverage over blind areas where you wouldn't get with a regular 5G network. But as others have pointed out, 5G is not 5G universally. The 5G deployments can be very different depending on where you are geographically, and even where you are regionally, depending on who's doing the deployment, what technology they're using, and how they're deploying it. It's been pointed out that China has really picked up the lead. It's interesting to note that Huawei really was the driving force in China for 5G. They came up with a way to solve a problem that nobody else came up with, and that was the backhaul. 5G towers tend to saturate the backhaul, that's the connection back to the central office. You have so much data coming into this cell tower that if you use the existing 4G backhaul, the backhaul saturates and you get too much traffic, and that traffic reduces performance. And what Huawei did uniquely is work on that backhaul and create a solution for cell towers that not only could go in without much technical support, one or two technicians are required, but had a far stronger backhaul. It's also interesting that the U.S. went after Huawei and blocked the company, given the fact that we don't make that technology here in the United States. The companies that do make the technology are largely European. So we for whatever reason, we went after a company that we didn't have a lot of skin in the game in terms of cell tower coverage. It's a fascinating thing with how governments work or don't work in this case. So finally, as we look at these IoT 5G rollouts, do recognize that a lot of what's going on is kind of a data balancing act. What do you collect at the edge? What do you transmit? And how do you avoid creating bias in the system so that the data that you're getting isn't compromised, and so that you can make decisions that are both timely and well-founded? My concern right now is we're not doing a good job with regard to balance at the moment, and data that should be sent centrally is not being sent centrally, and we're creating networks that are by design biased and could create problems with this going forward. Regulation is always lags the technology, and it's my belief that we're going to have a number of problems before the regulatory agencies step up and start to address this domestically as well as globally. In fact, globally, we're really a mess. There was some mention about using 5G for drones. Probably not a good idea, only because the network as it's laid out doesn't lend itself well to drone coverage, and most drones are using direct point-to-point radios at the moment. I'm not aware of an active deployment, military or otherwise, that are using 5G. It would be too easy to disrupt, and the coverage where you want to run it and the handoffs, particularly at speed, could be iffy. So even consumer drones, where you would think might adopt this relatively quickly, they are not. A lot of that also is because of the cost and data rates. You still have to tariff a 5G device where you don't have to tariff a drone that's going point to point, your radio, your receiver, so there's no charge, and so you don't have to put a SIM in it, and all you'd have to do is disable the SIM, and you could disable the drone. In fact, you could probably disable a entire run of SIMs if you found out the terrorists were using this, and ground their drones in the area almost immediately. And worst comes to worst, is you could bring down the cellular network to do the same thing. So right now, my understanding is nobody is seriously working on 5G for drone deployment right now. Though there is a concern when we bring up drones. We've developed a class of drones now that are relatively inexpensive, very automated, and can deliver an explosive package almost any place in the world. But the person that's deploying it has to be in close proximity, and that remains one of the limiting factors with regard to drones. I'm not saying that's the way it's always going to be, but right now I'm just not aware of a lot of development surrounding 5G and drones. There are just too many easy ways to disrupt the flight of that drone and bring it down. And you've got the folks that are doing this are relatively untrustworthy of large civilian organizations handling a portion of the solution. So it's an interesting time. Just remember that part we're not talking about, the bias part, is probably the biggest critical aspect of this, and it may create disruption in the future.
Thank you.
Rob, I would like to share with you that I didn't mean that they're using 5G with drones. That's not what I was talking about. I apologize. Okay. I probably miscommunicated it. What I meant is what they described on the BBC program was that people are using 5G for creating algorithms. Then they're porting the algorithms into different types of technologies that are offline, not online, and they can then deploy those drones to target people down the road. That's what they were describing. And I've seen some things similar to that, not to do with terrorism, but to do with other deployments. And so 5G network is interesting in that it's used partially to create algorithms. And then those algorithms are ported off and used in other technologies. So I just want to make sure that that's clarified. And I didn't intend to communicate that drones are being run by 5G. Thank you.
Okay, good. Yeah, you're right. The facial recognition stuff is a great concern for a lot of folks. We've got a major initiative here to try to block it broadly. And with facial recognition, you are using those distributed cameras that are increasingly 5G capable to capture the images. And if you were to compromise those databases, you could certainly use them in a very hostile fashion, whether it's to deploy drones or just to identify and cause grief for people, large-scale griefing. It can be problematic. So yeah, I gotcha.
And the other thing on drones is it's not just delivering explosions, it's delivering chemicals. One of the other big fears of it is we've already seen drones pulling cables over electrical distribution grid and knocking part of the grid off of the network. So it's not just explosion. There's many other ways that drones can be used to inflict pain.
Thank you. There are a few questions from audience. I want to take questions from Mr. Jason because I think he is responding, Mr. Rob. It's for Mr. David Schumacher. Is there any actual real science behind the stories I have heard about 5G being dangerous due to high radiations or something? What the real story?
Well, there's lots of talk about 5G and danger and many other different things. Let me say that I think the parameters that are behind this has to do with just the nature of 5G itself and the fact that you don't have large cells. You have a lot of emitters that are close to where the people are, where the data sources are. Because you have so many more of those, that you have more possible interaction for, and I hate the word radiation, by the way, too. People seem to think of radiation and they think of radioactivity and all kinds of other things. And we're talking about non-ionizing radiation in any of these cell phone signals. So the enemy is heat. So for example, going back to having many more emitters covering the area of, say, a traditional 3G or 4G area, you have more heat sources. So things like insects, birds, things that could pass by would have a potential for more heat. But we're talking about heat here. We're not talking about some magical, radioactive, undefined quantity. So that's what I would have to say about that.
Thank you, Professor Donalds from Onika. There is a question: how does IoT related to edge computing?
It's a good question. Let me expand just a little bit on what David just said, which is a way to think about the radiation is that it's very, very, very similar to what is going on with your Wi-Fi. So it's really not that much different. But that kind of interacts with something about the 5G that's very interesting, is that because people have this fear that there's some sort of mysterious force that's coming out of 5G, there's huge organized efforts to fight the deployment of 5G towers. So one of the reasons 5G towers in the United States are 5G is being slow to being adopted is that people are terrified of it, and they're suing the companies, and they're doing everything they can to block the deployment of 5G. So I think it's a really great idea to educate yourself about that and let everyone you know, just let them know it's really no different than the Wi-Fi that you have in your house. It's not. It's just like you have radio waves coming from television stations and radio stations and things coming through you all the time, and it doesn't hurt you. So it's just basically the same thing, and nothing to worry about. Okay, so let's see, what was the other question? Let me just find it here. There was another.
Yes.
Oh yeah, how does
IoT
right, IoT relate to edge computing? Okay, well, that basically, as someone right at the beginning very clearly pointed out, that really what IoT is little tiny computers sitting out there somewhere. So actually, if you look at my Fitbit now, it is a more powerful computer than the one they used on the first space mission. Far more powerful. It's got more memory. It's got more computer power. It's far, far more powerful. And I think of my phone, the first, like I had a web company, and this has so much more memory than I had disk space on the $7,000 server I got used, Spark 20, that I was running on my company, which was a huge computer, expensive computer. And this is so incredibly much more powerful than that you can't believe. So, I mean, in a way, your phone is an IoT device, because it's constantly interacting with a central, some sort of central things. You're interacting with websites. You're interacting with your information is being backed up. When you look at your pictures, I keep mine on Google Photos. I don't keep them on my phone. All my phones are uploaded to the cloud. So it's an IoT device. The computer in my refrigerator is very sophisticated. I can download apps and put it on. It's an IoT device. My Fitbit is constantly talking to my phone, and so it's an IoT device. And so what winds up happening is, as I said before, is if my Fitbit is or whatever the name of the new Amazon thing is, if it's listening to my voice tone and trying to make a decision about whether or not I'm sounding pleasant or angry or whatever else like that, it's doing edge computing, and if to train the recognizer is an extremely time-consuming and difficult, compute-intensive thing to do. It requires millions of samples of voices, billions, hopefully, and takes just an unbelievably fantastic amount of computing power. We knew how to do deep learning, I think, in the 60s or even 50s, but we couldn't do it because there wasn't enough computational power and there wasn't enough data available to actually be able to do it. But then now we can do it, but you can only do it in places like data centers at Amazon and Google and places like that have enough computational power. So your devices are the edge, or anything is the edge, and then the computation takes place to train these devices in the cloud at these central places, and then it's downloaded into your IoT devices that you happen to have, like your Fitbit or your phone or your refrigerator or whatever it happens to be. And the actual processing takes place on your Fitbit or your phone or your refrigerator or wherever else like that. And that's what edge computing is. So that's how that works. So that's the answer to that
Thank
question.
you. Thank you. Professor David Smith, I have a question. What are the potential applications and benefit from usage of 5G mobile technologies within manufacturing facilities?
Well, 5G technology is really applied where they need increases in data transfer speed, where low latency is necessary, because 5G networks are promised to give sub-millisecond type response time. So if I'm in a manufacturing environment where I'm reading a lot of sensors, reacting to the sensors, if I'm in a manufacturing environment where I'm doing small lot manufacturing, have to change the programs in the robots and the other processing tools I'm doing, 5G has an innate ability because of the speed, the low latency, to be able to do things like that. So there's applications there. The things that were mentioned earlier with the Samsung View at 6G, 6G is beginning to look even more involved at the latency and the reaction, but that's still a ways down the road. 5G as a solution in fixed installations is moving a lot more rapidly right now than 5G in a mobile environment. And you're going to see that. The other place where 5G in manufacturing in particular is going to play is we're seeing manufacturing where the supply chain, the logistics is becoming more and more challenging. And because of that, the old concept of just-in-time manufacturing is being stretched to its limits because of these logistic disruptions. And to begin to apply more sensing technology, more Internet of Things to help manage your logistics and using the 5G networks is going to be a plus for manufacturing, because I can tell you from looking in electronic manufacturing, auto manufacturing, aerospace manufacturing, they're all being impacted today by hits in the logistic chain, in the supply chain. And that is going to be a big disruption for manufacturing, I think, for the next 24 months at least. And 5G combined with Internet of Things, combined with edge of cloud computing, is going to be part of the solution to bring that back under control.
Thank you. For Mr. Marshalls, yes. From Alea, what are the relationship between edge and cloud?
Well, I think what David brought into perspective, David Smith just brought into perspective, kind of addresses this as well. It's interesting when people are always confronted with challenges or problems, such as the supply chain issue that we are all experiencing because of the pandemic, and the pandemic keeps hanging out there, and we may have more of this, we may not. Because of uncertainty, what we're able to do is use this technology to overcome some of the challenges in the supply chain. But in addition, the reason we're able to do that is because of the connection between the ability to drive down the latency of information and data, and how to use that in all the aspects that David Smith talked about, but so did David Shoemaker and Donald talked about, and Rob talked about previously. The deployment of this technology in the cloud is really important, because the cloud is actually expanding at an exponential rate. And as it expands at an exponential rate, and there's more storage space out there, we can handle more data, and the more data that we have as it gets, and it was pointed out by Donald that the data is handled at the edge through the IoT device itself. And one of the things that is happening that's being developed, and I know this is being developed in the US, but also in China through Huawei and the others, is that they're looking at being able to use the data at the IoT side to go out, reach out to the cloud, take the data, process it, move it back, and give new instructions or new deployment information to the IoT device itself. So what we're seeing is a transformation of data driven material that is I think is going to be it is revolutionary, but it's going to always be revolutionary. That's the issue of adoption of innovations. Innovations are always revolutionary by their definition. The question is, will they fall into a chasm or not? A lot of people have believed that because of the pandemic and because of the collapse of the world economy, we would be, and this latency of in terms of the supply chains, we are kind of in a big problem. But I think that this technology itself, the interaction of IoT at the industrial level, not necessarily at the consumer level, but at the industrial level in manufacturing capacities, will be addressed over time through the 5G capabilities, let alone 6G. I'm not so sure that we're going to worry about 6G right now, as David Schumacher pointed out. That's down the road. But the 5G is here. It's here in stages. And as somebody pointed out, it's in 3 different levels. But as those levels get deployed and as we find solutions to the deployment in terms of the cost is really, I think, one of the issues that is being addressed right now. And that cost will come down over time. And the 4 main competitors out there are Japan, South Korea, China, and the U.S. The other players, relatively speaking, are smaller, and I think unless they come up with something that's unique, I think we're going to look towards those four economies to actually drive 5G and get the kind of results that we need to get the economies back on scale in a more rapid fashion than we're seeing currently. I think we're going to see that coming up, and I think somebody predicted 12 to 24 months. I would say that's probably pretty accurate.
Mhm. Thank you. Professor Rob, that is the final question for today's discussion. What companies are working in edge computing worldwide?
Well, I don't have a comprehensive list on the top of my head. The companies to follow are Qualcomm, certainly here in the United States. Intel's working on this as well. Mostly from the central office standpoint, but they've got low-powered processors as well that can be put on the edge. Let's see, Huawei we mentioned in China is active. Cisco, the networking giant in the United States, is working on this. And then there are a variety of companies. Samsung, LG in Korea are both playing in this area, and there are a number of other companies working all over the world. The large providers like Siemens, cellular companies like Siemens are also in play here. So it's most firms that are building anything has something to do with edge computing. We mentioned the automotive companies in the past. As we move to autonomous driving, that's a major focus for edge computing as we deploy that particular technology. Robotics, both military and domestic robotics, are focused on using this computational power at the edge to expand their networks and increase their capability and offset to a certain degree the massive shortage of manpower that we currently have. We are a world in flux right now, where we're rediscovering where we need to do processing, how we do processing, and specifically what the impact of that processing is on individuals, and particularly individual privacy, which is a growing and currently very large and well-founded concern with regard to the deployment of these sensors. These networks are also being heavily used in efforts to mitigate climate change, global warming, and to both identify the sources of the problem and eventually perhaps to come up with large-scale ways to mitigate it. Because when you're talking about weather events, the only way you're going to mitigate a weather event is with something incredibly large at a scale that we currently are not capable of operating. But with edge computing, there is at least a possibility that we could, and certainly a very real probability that we at least can use it for faster alerting and for the better deployment of resources and for helping people find safe places to be. So it's this process of digitizing the world, and of course, in the large scale, in terms of the metaverse and digital twins, it's this capability that will keep those digital twins in sync with the real world and allow us to do realistic simulations at scale without putting people at risk. So it's got broad implications for not only how we view the world, but how we interact with it. And any company that is dealing with either of those two things probably has at least a toe, if not a foot and a leg, involved in endpoint computing.
Thank you everyone for joining today's sessions, and especially I request all of our audience, please share our content as much as possible with your government, with corporation and academy. Beside that, World Talent Economy Forum, we are trying to solving many problems of developing nations. Every moment we are getting different challenging problem. So those who want to work in our team, they can join, they can collaborate. This is very dynamic problem. Example, from aviation industry, we are getting problem. From developing world, from stock market, we are getting problem. For waste management, we are getting problem. There are a lot of challenges in the developing world. Good point is that this is the achievement of our speakers, our board of advisors, that many countries, many corporations, many government, they start to believe that World Talent Economy Forum is the forum, those who can solve many problems of the developing world. So I request our speaker, those who want to work in our core team, they can, and they can solve many problems of the developing world. Beside that, the audience, those who are sharing, always you sharing a lot of challenges. So definitely with a specific period of time, I will and my core team will support you. This is our commitment. Already we just finished our dialogue with Rwanda, and we are offering like job for 300 people in Rwanda. That is our good achievement. In the School of Talent Economy, we are providing training. So already many students and the youth community, they are joining. So hopefully in between 3 to 6 months, we can give them a very good result. So World Talent Economy Forum, we are very much action oriented. We are working hard. We need support because we need to do the teamwork. And I'm sure our board of advisors and our speaker, they are very capable to solve many problems. So that is the thing. So thank you everyone for joining today's session. I directly want to go for the concluding remarks. Before that, I just want to add, we have some of the exclusive debate in World Talent Economy Forum. We are trying to arrange a debate in between AI and human with AGI Lab. Beside that, with the Muslim world, I live in a Muslim countries. It's a Malaysia. They are also collaborating with World Talent Economy Forum. So soon we will focus on Islamic finance, and we will develop a research team, and we want to develop an ethical financing procedure for the Muslim world. Even from our speaker, those who are interested to join in our research team, support our research teams, we are open. Because we are engaging with as much as possible with different corporations, government, and academy. So maybe a lot of challenge will come, and we will solve together. So thank you, everyone. So I request Professor David Schumacher, what's your concluding remarks?
Yeah, thank you, Sharif. We've talked a lot about 5G today as it relates to edge computing and IoT. Concluding remarks, I want to say that 4G LTE is not dead. As a matter of fact, it's very much alive. Here in my home state of Arizona, 5G is pretty much concentrated in the downtown Phoenix area and on the university campus that's not too far away. Very spotty everywhere else. And as you move out into rural areas, they're not going to see 5G for a while. And when we move out internationally, we're going to see 4G, 4G LTE in many places for a while. So why do I bring this up in concluding remarks? Because IoT is still being driven by demand, and you'll use what communication technology you have at the time. Edge computing is more easily deployed right now, especially with the move has been among carriers to virtualize close to the edge. So virtualizing close to the edge and processing allows developers, and this is a key point, I think, to develop applications that can later run maybe in a more robust mode in 5G when 5G connectivity is available, but be able to do that now and be able to start to roll out products to end users, whether they be somebody with a cell phone or whether it be a company that wants to monitor processes. If we can begin to do that now, and we can begin to drive adoption of new ways of using software even before we have 5G fully implemented. So I know that's going to be an aspect here in Arizona where I live, probably in Malaysia, and probably where all of the other speakers are located as well. So good to focus on what's down the road, but also I like to focus on what we can do with it right now. Thank you.
Thank you. Thank you. Professor Donald.
Well, I really want to piggyback on David's excellent remarks, which is, you put it into perspective, as I was saying, that in order to get very good, the super high bandwidth, the highest tier 5G, you have to be very close to the tower, which means there has to be lots and lots and lots of towers. And each of those towers has to be connected somehow back to the back office, backhaul, which is one of the biggest problems, and which might entail digging up somebody's front yard and putting an optical cable through it and all kinds of stuff that's incredibly expensive and problematic. So it'll be, however, as David pointed out, that's not necessarily a problem because, because that's where the edge computing really becomes valuable, because when you, just to understand it, if you're not technical at all, when you log into a website, there's a delay between the time that you click and the web page comes down, and sometimes that delay is longer and sometimes that delay is shorter. So if you're using a program that's actually running in the cloud, you are going to have that delay between the time that you ask the program to do something and then that program responds to you and it does something. If the program is local on yours, you don't get that delay. I mean, the only delay you get is the delay that it takes for the program to do whatever. And so designers can design programs so that they wind up asking things that take a long time at the same time they're doing things for you so that they keep you entertained or keep you doing things that you need them to do. So you can design software so that delay really doesn't create a problem. In fact, people do that with web pages. I mean, the delays are there, but you usually don't notice it because people are sophisticated enough to make the web pages do things for you so that you don't see the delay. In fact, in a way, web pages, since a lot of them are JavaScript programs that are running in your web browser, they're edge computing in a sense, because that's what they are. They're so I think that I want to make one other point there, is that the way a lot of what we're doing is, instead of 5G, we already have Wi-Fi that works perfectly well at super high bandwidths. And so mostly if we want to do the kind of thing that we're hoping to do with 5G in the future, like right now, we can do it because we just have Wi-Fi. And so organizations, companies, whatever, that want to have IoT devices that work really well, They just hook them to the Wi-Fi. That's what I hook my refrigerator to. My oven, my refrigerator, they're all hooked to the Wi-Fi. And so I don't need 5G for them to work at super high bandwidths. So I think that 5G is exciting, and it's an interesting thing that'll be happening in the future, but it's not really here yet. And I think 2 years would be extreme. Well, let's put it this way. You can't even get good 4G reception in a lot of places because they can't afford to put cell towers close enough together for you to get 4. And considering that how close the cell towers have to be together for 5G to work at optimum speeds, there is no way that most of the world is going to have the top tier 5G. It's just not going to happen. So I think that looking at how you can develop things that work, that deal with the latency, is probably a really smart thing to do. So that's that.
Thank you. Yes, thank you. Professor David Smith.
I agree. There's challenges going forward, and we should use the technologies we have. I was involved with a forecast last year that looked at 5G penetration for mobile devices on smartphones. And the forecast that came out of that was that by 2025, globally, only 1 in 7 smartphones will be 5G. So it is going to be more of an uptake for a consumer type of experience. In the commercial applications where you see it, it's going to be a little bit faster. But one of the things we need to realize is that there's many 5G and cloud and edge computing. They require investments at many different industry-wide investments. There's investments in radio access. There's investments in fiber, particularly deep fiber investments. There's investment in switching, in all type of different type of smart switching, in metro transport. In the core network, there needs to be quite a few of upgrades. In this service operation, there has to be infrastructure upgrades. And finally, in the subscriber ecosystem, with the 5G devices, the consumer devices, the laptops, the Internet of Things gateways with indoor access with these small cells like Donald we're talking about. All of these are infrastructure investments that have to be made for IoT, 5G, and edge computing to work globally. So it's not like any of these are in isolation. The entire network and the network ecosystem has to be upgraded to handle them. Not only that, we need to produce professionals who understand the nuances of them. As we saw professionals who grew up with 2G and 3G wireless networks, going to a 5G network is not the same as just doing what you were doing before. It requires a new mindset. It requires a new way to look at how the protocol stacks work. I can do a lot of things now at different levels of the protocol stacks than I could do back with the older networking technology, which makes it places where I can take some real advantages, particularly when it comes to edge computing. I do not necessarily need to use the whole protocol stack with edge computing to make it effective and to do those things. So education has to change. And finally, regulatory has to change. One of the places that we see that the Internet of Things and edge computing really could be a driver is to go to the very short wavelength type of spectrum. And right now, that's licensed spectrum that is not allocated in many places around the world to those type of uses. So the governments that manage the spectrum need to work with the end users, the companies, and actually academia to make the regulatory environment work as well. to let Internet of Things, 5G, and edge computing have the velocity we think it can have.
Thank you, Mr. Marshall.
Yeah, so for my concluding remarks, I agree with what David Smith just said, and also David Shoemaker and Donald, and I'm sure I'm going to agree with what Rob is saying. We're on the same page, all of us. One thing that I do want to point out, though, is we are in a world environment. And I think a lot of the conversation that we're having here has to do that it's US-centric, a lot of the comments. To give you some data, South Korea, 5G wireless network systems have been available since late 2018. Already, we know that 30% of the market has been saturated with 5G, and that was as of 2020. I think now in 2021, even with the pandemic, it's rolling out exponentially. We're going to see that happen in other parts of the world. And then the question becomes, is the United States going to be leading it? Is it going to be behind it? It's a big race, because the race of this technology is, even though we are using 4G LTE right now, and I agree, that's what we're using dominantly. But here in the Hudson Valley of New York, I can tell you right now, 5G is expanding exponentially at a rate because of the Sprint network being acquired by T-Mobile. T-Mobile is completely 5G at this point in New York State. I don't know about Arizona, but that's what they're doing. And they're expanding that tremendously. I agree that part of the adoption curve is problematic because of the latency issues and because you need to be close to these cell towers. But I think what's going to happen is we're going to find that cell tower technology is going to be deployed in a different way than the towers that you need today for 4G LTE. We're going to see the technology, and I'm already seeing it here in the Hudson Valley, that they're deploying small pieces of technology that are 5G enabled and for broadcasting, and they're not on a tower. They're on farms, and they're on fences. It's really amazing what we're seeing here. The other component that I want to talk about is what I think, which was a good point that Rob brought up, that is we're beginning to see, as everybody on this maybe not everybody on the panel, but a lot of the viewers have seen me on other panels. Most of my conversations are about climate restoration and climate repair. That's what I'm focusing on with our business. And using these different technologies is going to be critical to advancing climate repair and climate restoration at scale. And I think somebody mentioned the scale. I think it was Rob that mentioned the scale that needs to be done has to be enormous. It has to be worldwide. And that's where I see the latency issue diminishing, and Internet of Things combining with 5G, possibly 6G down the road, and with the other technologies that we're bringing to the table right now are going to be critical in being able to deploy systems that can sequester GHG emissions, improve soil health, improve water quality, and at the same time prevent zoonotic diseases, which, by the way, are caused by climate change to a certain extent. So my example of that is the issue of Creutzfeldt-Jacobs disease, which came from mad cow disease. I'm not talking about the current COVID-19, but current COVID-19 is a zoonotic disease between species. And a lot of that species stuff is that climate is changing and driving species into different areas, wild species. Obviously, the other species that I'm talking about is livestock. Livestock it goes into the food chain currently, and that can cause zoonotic disease to occur. So we need to address all these issues. I see that these technologies, edge computing, Internet of Things, and 5G being advantages to climate restoration and climate repair. Thank you.
Thank you, Mr. Marshall. Professor Rob.
Okay, edge computing is it's kind of the future of our increasingly digitized world. Some comments were made earlier with regard to health concerns with regard to 5G. Nothing has been connected to 5G towers. Doesn't mean that they're not causing problems, but nobody's found one yet. There are issues that have been connected to high-powered transmitters, 4G or 5G in cell phones. It changes the structure of your brain. But so far, no adverse behavior has resulted. It does concern me that we've had brain changes, but no personality changes, no illnesses associated with that. But my typical advice is if you get a choice, use an earbud or the speakerphone feature on your phone. Don't make a habit of holding it up against your head. You'll probably be fine. We're talking about edge computing, and the issue with edge computing, as with any computing structure, is to make sure that it's used for good, not for ill. With any technology, it is not inherently good. It's not inherently ill. It can be used for either, and assuring that it's being used for good should become a predominantly bigger driver than I think it is. There were comparisons between 5G and Wi-Fi. I do recognize that industry to a large extent is moving away from Wi-Fi and towards 5G. What's doing it is because of rogue access points. Wi-Fi is relatively unsecure. The easy way to break into somebody's home or small business is to set up a rogue access point with the same name as the access point on the site, pound a device that's connected like a printer until it disconnects. And then as soon as it disconnects, create a rogue device that identifies as the printer and connect to it. The network doesn't know any difference. And now you're in the network. And unless you've set up permissions, you've got full access. And so the concerns with regard to Wi-Fi being inherently unsecure have been driving a shift to more central office technology in 5G. It doesn't mean you can't have rogue access, cell sites either. We've got those. They're just a lot less frequent than the rogue access points. Rogue access points, particularly in emerging countries, have been a serious security problem. Not only when penetrating a business, but when you're remote. If you connect to a rogue access point, it can download malware onto your device, and you've got a problem. It doesn't really happen that much with regard to either 4G or 5G or cell sites, though you can have issues, of course, with hostile websites as well, which can do much the same thing. Finally, as we move to this next generation of autonomous technology, this endpoint computing becomes much more pronounced. It's critical for robotics, for autonomous cars, autonomous delivery vehicles, and even autonomous planes. The disruptive factor that's coming through is using some type of satellite link instead of a 5G central network. Tesla's pushing that pretty hard with Starlink at the moment. Right now, he doesn't have the capacity, but they're talking about putting thousands more satellites up into space, and that could provide some interesting advantages if they can solve the downlink saturation problem, which is similar to the backhaul with regard to cell sites, becomes a place where the signals will saturate once it gets to scale. Figuring out a way to provide the very broad, very high bandwidth downlink has been somewhat problematic at scale. So we'll see what happens as they scale up Starlink. And my own hope is we finally can get Wi-Fi working on airplanes again, which is where initially we'll see the biggest impact. In the end, though, we're talking about a change in the world, a change in how we do things, and like anything else, it means disruption. For an emerging economy, it provides an opportunity to jump ahead, deploy the latest technology first, where merged companies have to displace existing technology with something new. An emerging economy doesn't have that drag on the deployment, and often they can leap a more advanced area by simply not having to deal with the legacy infrastructure that they otherwise would overcome. And in closing, perhaps looking at wireless backhauls as a way to deal with the backhaul problem. That's what Huawei did, and what allowed them to stand out and move much more broadly than the other providers is go fully wireless. Don't go with a wired backhaul, go with a wireless backhaul, high bandwidth. It allows for much faster deployment, much lower cost, and it saves you from what Donald was talking about with regard to digging up people's backyards and dropping fiber, which can be extremely expensive, particularly in rural areas.
Mm-hmm. Thank you. This is really great discussion, and especially I'm sure for our audience this will be very good content. And I request please share our content even in the classroom, because in the classroom you can develop different case study. Even you can share your views, what you learned from our open dialogue. as well as if you have any questions, you can share with us. I'm sure our speaker, they will be happy to share their views based on your questions. So thank you everyone for joining today's sessions. Even from my side, I just request any organizations or any corporation want to solve problem, uh, climate change, they can join in World Talent Economy Forum. They can solve problem in aviation, because aviation has a lot of challenges, and many aviation corporations, they communicate with World Talent Economy Forum. They need solution and support. So any speakers, any organization want to solve this problem, we are open for that. Beside that, water and energy also important. So those who want to solve these things in Asia Pacific, we are open for that. So that is the things we are developing a very strong team. Our objective to solve many problems of developing worlds. So thank you all of our speakers, Mr. David Schumacher, Professor Donalds, Professor David Smith, Mr. Marshall, Professor Rob, for your continuous support for World Talent Economy Forum. Bye bye and take care.
Bye-bye. Take care.